Hello, this is Sadbir. The topic of our discussion in this video is how to compute column space and null space of a matrix. Before we calculate the null space and column space of a matrix, we need some definition. So our first definition is what is a echelon matrix. So echelon matrix is of this form. When you have if you have a pivot in a column, all the entry below the pivot are 0. So for example, here, all the entry below this pivot is 0, and for this, all the entry below this pivot is 0. The entry above the pivot and all other entry can be non-zero, but the entry below the pivot must be 0. I can give you an example. So suppose 1, 0, 2, 1. That is a echelon matrix because this is the only pivot here and the entry below that pivot is 0. Another matrix 3 by 3, 1, 0, 0, 0, 2, 3, and then 1, 0, 0. As you can see, this is the pivot element and the entry, that pivot is 0, and this is also a pivot. All the entry below that pivot are 0. Our next definition is what is a reduced row echelon matrix. And the reduced row echelon matrix is when the pivot is 1 and all the entry below the pivot and above the pivot are 0. So as you can see in this matrix, there are 3 pivots. All the entry below these pivot and also the above these pivots are 0. And all the pivots are 1. For example, so 1, 0, 0, 0, 1, 0, 0, 0, 1. This is a very famous matrix, identity matrix. This is also a reduced row echelon matrix. And 1, 0, 0, 1, 0, 0, 1, 0, 0, 0, 0, 0. This is another reduced row echelon matrix. Here are first quiz problem. Please pause the video for 1 and 2 minutes and work on this problem. Finding the column space and null space of a matrix. First, we will calculate the column space of the matrix, of this given matrix A. In order to calculate the column space, the first step of the solution, the first step will be to reduce that matrix to row reduce echelon form, REEF. So we will use the Gauss-Jordan elimination method on the matrix A to reduce that matrix into a row reduce echelon form. So as you can see that the very first step of the Gauss-Jordan elimination would be to eliminate this entry and this entry, because very first pivot is our first non-zero entry in the first row, which is a -3. So we will eliminate all the entry which are below that pivot. So I will operate on R2. My operation will be R2 minus 1 minus plus 1/3 R1, and I will operate on R3. R3 plus entry to be eliminated is a 2. The pivot is a 3, so -3, so negative, negative, positive, and I will operate that multiply to 1. These operations, our matrix will reduce to this form. So then we will calculate the second pivot. Second pivot is the first non-zero entry in the second row, which is a 5/3. So I will eliminate the entry above and below. All the entry which are above the pivot and entry which are below the pivot. So in order to eliminate 13/3, so I will use the operation on R3. So on R3 minus entry to be eliminated is 13 divided by 3 and the pivot is 5 divided by 3. So this is a 13 divided by 5 and you multiply that to R2. So I will use that operation to eliminate this entry. Next, we will eliminate this entry, which is a negative one. My operation will be on R1. R1 minus entry to be eliminated is a negative one, so that will make positive one. Divide by the pivot, which is a 5/3, so it's going to become 3/5 of R2. Now the last step of this process is to make this entry, this is our pivot, and this entry 1. So to do that, I will divide the row 1 by -3 and divide the row 2 by 5/3. So now if I apply the operation on R1 minus 1/3 time R1 and on R2, basically 3/5 time R2, that will reduce the entry, the pivot entries into 1. So this matrix is our row reduced echelon form of A. This is an important matrix for us, which is a row reduced echelon form. So first let me take that. So now we will calculate the column space. To calculate the column space of the matrix A, you need a special vector in this space. There are two special vectors, the one which contain the pivot. The pivot columns are, so this is the column which contain the pivot and this is the column which contain the pivot. So the column number 1 and column number 3, they are the two important columns which I place into my column space. These are the special column, -3, 1 and 2. And the column 3 of the matrix, this is a column 3, -1, 2 and 5. So these are the two vectors which will generate the whole column space. It means all the linear combination of these two vectors will be a column space. So notice one thing, the column space of A is subspace of R5, R3, because there are three component, 1, 2, 3. There are three components. So column space is the subspace of R3. So since the column space is a R3 and this one has two vectors, so it means in R3, any linear combination of two vectors will be a plane. So this is a plane in R3. That is our column space. Geometrically, it is a plane in R3. Now we will calculate the null space of this matrix. The first step of calculating the null space is also to find the row reduced echelon form of the matrix A. Since we already calculated the row reduced echelon form of this matrix A in the previous video, so I will write this one. It was 1, -2, 0, -1, 3. That will be 0, 0, 1, 2, -2, and the last column is all 0. To calculate the null space, we need to calculate all the solution of the system Ax is equal to 0, because null space is the solutions of when the right hand side vector B is 0. So what I will do, I will take my x is a x1, x2, x3, x4, and x5, and then I set that is equal to 0. 0, 0, 0, 0, 0. If I multiply this matrix um, to this, I will get this equation x1 minus 2 time of x2, x3 is 0, then minus x4 plus 3 time of x5 is equal to 0, and I will get x3 plus 2 time of x4 and minus 2 time of x5 is equal to 0. This is when I multiply this matrix by this column, and I set this equal to 0. Now we're gonna identify what is our first pivot column. So these are our pivot column, and this is our pivot column. So these are the two are pivot column. So the column which are not pivot, they are also gonna play a very important role. So this and these three are not pivot column. So x3 I can say on the place, sorry, x2, x4 and x5. These variable are free variable because they are does not contain any pivot. So I will calculate the three solution based on this three free variable. So this is I will call free variable. So my first special solution is going to be right first. This is my first special solution. I'm going to call the special solution. So I have x2, x4 and x5. These are my free variable. I'm gonna assign the value x2 1, and I'm gonna assign the rest of these two 0 value. Now if I plug these values x2, x4 and x5 into this system, the linear system I will get x1 minus 2 time of x2, which is a 1, x4 is 0, x and 5 is 0. So that will give me immediately my x1 is 2. And if I plug into the second one, x3 and x4 and x5 are 0. So everything is equal to 0, x3 is equal to 1. So this gives me a one special solution. I'm going to call it V1. It gives me x1 is a 2, x2 is 1, and then x3 0, x4 0, x5 0. So this is my first special solution. Let's compute the second special solution. Second special solution. To calculate the second special solution, I will take x2, x4 and x5. These are my free variable. I will assign this time 0 to this. I will assign 1 here, and then I assign 5 to 0. So basically I switch 1. This time I will assign x4 1, and I assign the rest of to the 0 number. So if I do that, I can see if I plug back into this equation, the very first equation is going to give me x1, x2 is 0 this time, x4 is 1, and x5 is 0. So this implies this is gonna give me x1 is equal to 1. And if I plug then the second equation, which is gonna x2 is 0, x3 and x4 is 1, so that's going to be a 2 times 1, and x5 is 0. So basically x3 will be, in this case, a negative 2. So my second special solution is V2, which is now x1 is 1, and x2 is 0, x3 is a negative 2, x4 is 1, and x5 is 0. That's my second special solution. Now compute the last special solution, the third special solution. Third special solution. To calculate the third special solution, you assign x to 0, you assign x4 0, and this time you assign x5 1. So basically you keep switching 0 and 1 between x2, x4, and x5. So again, if you plug back this into this system, these two equations, and your solution is going to be this time x1, x2 is 0, x4 is 0, x5 is 1, so x5 is 3 is equal to 0. This gives you x1 is equal to negative 3, and x3 minus 2 times x5, which is 1, so this implies x3 gives you 2. So that will give you what is your V3, which is a third special solution, and it is x1 is a negative 3, x2 is 0, x3 is 2, and 4 is 0, and 5 is 1. So these are my three special solutions. So once I have these three special solutions, I can write down the null space. So in order to write down the null space, I'm gonna eliminate these. So now I have all my three special solutions, so I can write the null space. The null space of the matrix A is, it is basically the linear combination, all linear combination of my special solution of these three vector. The very first vector is a 2, 1, 0, 0, 0, and then it is 1, 0, negative 2, 1, 0, and the last vector is a negative 3, 0, 2, 0, 1. It contained three vector, so it's a linear combination of three. So notice one thing, that the null space of A is a subspace, of R to the power 5, because it has a 5 component. Each vector contains 5 components, so it's a subspace of R to the 5. But since it contains only 3 elements, so it is a smaller space than R5. So it's not a whole R5, it is a smaller than R5. Here is your second quiz problem for you to practice. Please pause the video for 1 minute and work on this problem. This is also the end of this video. Thank you very much for watching. I will see you in the next video.